Hi everyone, this is Miss Granucci. I'm here to do a little tutorial on Excel. I assume you might have either heard of Excel, you may have used it before, but what I want to do is just give you a kind of like a synopsis and an overview of how to use it, especially because we're going to be using it a lot in physics. So I want you to feel comfortable using it and find out that Excel is actually not so bad, and it's actually your friend if you know how to use it. So in this video, what I'm going to do is show you a little bit about Excel. I'm going to do it in two parts, if you will. The first part, I'm going to show you how you can use Excel to do multiple calculations. So I know often in lab you might take lots of data and you might have to calculate something like an average, and you might have to do that for every set of data points. The cool thing about Excel is that you can actually have Excel do it for you, so you're not mimicking all these calculations and you can have them right away. The beauty of doing this is so you can, of course, do this much faster and focus on the data analysis, which again is important in physics. So as you can see, what we're going to do is I'm going to show you how to import data. In other words, just how to enter data into your Excel sheet, how to generate calculations, just show you a couple functions in Excel that are really helpful, and some error functions that are very helpful in Excel. The second part of this video will be, I'll break it up into two parts, is the graphing part. I'm going to show you how to graph in Excel, specifically physics stuff. There's much more to Excel than I'm ever going to get to, but I'll show you the basic stuff. But I'll show you how to make a graph, add trend lines. If you have to adjust the scaling, it's actually not true. It's not really straightforward. So I'm going to show you how to do that if you need to adjust the scaling. And a little bit of error analysis with the graphing. What does the R squared mean? How does it represent data, etc., like that. There'll be about 15 minutes per video. Okay, so first thing we're going to do is get into our Excel file. So I'm going to locate that on my computer. So judge a million things open. So I know you can't see this at the moment. Can I move this over? Oh, I could. I don't know if it allows. Okay. So I actually have the Excel saved to my taskbar here, just so it's easier to get to. Of course, I use it all the time. If you can't find it here, then you can go to your Start menu, which is probably where it would be. And if you go down to, you either might have it here where it says Excel. This is my personal computer, so I probably should have used the other one. But if it's not there, you might find it in the Office Tools section. Of course, it's not listed here, but anyway, it should be easily found in this Start menu if it's not already there. So here we go. I'm just going to adjust this again. Okay, let's do that. There you go. All right, so this is an open Excel sheet call. If you notice, there's the sheet down here. It's nice to, if you need to do multiple things, open various sheets so you can just tab it, just like you have tabs for your websites. You can tab it here. Okay, so I'm going to make up the data just for our purposes here. So just give me a second to do that. So these things that I highlight are called cells. And the cells have names. So this is D2, this is E2, etc., like that. So this is the rows and these are the columns. And literally this can go on forever. I've done work with galaxies and it's used as many as like 100,000. Literally, I'm not kidding, 100,000. So this thing is pretty big. So let's pretend we're doing some linear motion data. Generally, when you're in my class, these are specific to my class. Of course, you have to follow directions for other class. A couple good things just to do is, of course, write your name on things. So make sure you write your name. So here's my name, Nicole Granucci. It's always good to give me the class. Let's go Physics 1, why not? It's always good, it's a good habit, is write the date. So, this is August 11th, 18, no, 17. Let's go with this year, etc., like that. So you can actually write this infinitely, as you can see. So the cells don't necessarily block off right when they do, but what you can do is a shortcut. Say this was the case, you can actually take your mouse and hover over this, and if you double click, it automatically adjusts to the size of your writing. But we don't want all this there. I was just being silly, clearly. And if you double click there, it adjusts to the size, so it makes it the perfect size. Now, this doesn't actually print off any sort of lines, so I'm going to go ahead and do this too. Now, I really don't have a preference right now where all this stuff goes, so I'm just doing that. But what you could do, well, I'll skip the lines right now. So let's say we're having motion data. So one thing you might have is a distance measurement. It's always good to write down the units in parentheses like this. And let's say we're going in orders of 10. Cool thing about Excel, so maybe you need to do in orders of 10 for a while. Shortcut for Excel is if you highlight the 3, Excel says, oh, I get the pattern. You're going by tens. So what you do is you highlight the 3, and then there's a little crosshair right here. And if you click and drag, it recognizes the pattern for you. Pretty cool. So there's a shortcut for you. It only works if you have a pattern, and it has to be replicated. So obviously this was in orders of 10. Because I like things in the middle, I'm just going to go ahead and use that button right there to change the alignment. Not necessary, but let's pretend. So one thing we're going to do is maybe a time trial. So time trial 1, and we should put the units, put it in seconds. Now, for Excel, it's important that you put the units in the title and not in the data, because Excel wants to do calculations, and if there's numbers and letters, it doesn't know what to do with it. So I recommend that you put the units up here in the titles instead. And it's important that you label the units because the scaling will matter. So, and then try to be consistent. So in other words, you know how I did that right there. Let's just be consistent here. And this should be time trial 3. So if you double click, you can edit that. Okay. Naturally, what we're going to do in lab is, we'll have all these time trials, and then we want the average. We use, a couple time trials to, of course, understand how the data is being collected, what are our outliers, things will change, so taking an average kind of gives us a general idea of our data. So let's do that. Okay, so I'm not going to do all of these. In fact, let's just keep it a little simple for now, just to show you that you could have done that. So I'm going to make up some data here. There we go. Let's say this is your data points. I'm purposely going to do a non-linear data set here. And let's go 5. So I know this is fun. Let's make a really big error here. Okay, and then let's do, I don't know, weight is 6. Let's go to 8. So I know this is lots of fun. You're enjoying this. Let's make this that. So again, what I'm doing here is I am not putting any units. That's the important part when you do this. Much. Okay, let's go to 15. Like I said, just making up the data. When it comes down to decimal places, it depends on your measurements. So in this case, you can see that I'm using 2 decimal places. That's usually true when you're doing time measurements. But it really just comes down to what you're using. So as always, be consistent. So if you're using 2 decimal places, use it for the entire spreadsheet here. And then we'll go big here. Okay. Okay. So once again, this is just me. I like having things aligned to the center just like that. All right. So, one thing in lab might be to calculate the average of all these. So you can do that. Average is you add up the 3 and divide by 3. It's not a hard calculation. But what you can do with Excel is you can press the equal sign. As soon as you do that, it becomes a calculator. So just a couple examples. If I do 5 plus 5, oops, 5 plus 5, and you have to press enter. It calculates it. It's 10. you have to start with the equal sign to do any sort of calculation. You could do 4 times 4, 16. You could do 4 squared, oops, 4 caret, oops, 4 caret equals 4 caret 2. See, it works just like that. It can even do square root. So notice that when I did that, it said, oh, you're doing a square root. What's the square root you want to do? Let's do 16. 4. So it does all sorts of really neat calculations. So one thing you might want to do is the average. So if you press equals and you start writing, it's going to give you the ability to select different functions. So there's all sorts of things you can do with this average. You click on it, it tells you what it is. So this is average and it has like arguments. So average if you want to do this. So don't worry about that. We're just going to go ahead and use this one. This is just an average. This is a simple average here. Now if you double click on this, you'll see that it says average. I'm going to calculate the average for you. What are your numbers? The best and easiest way is to highlight the cells that have it. So notice that this is cell C6, and notice that it's up there. I know I'm pointing to it. I know you can't see that. But if you highlight the 3 numbers that you want, just like that, and this is reading C6, so that's this one, through E6. So this is the same row, just different values right there. Now, in order to execute the calculation, you must press enter. So I'm going to go ahead and do that. And voila, there's our calculation. So of course this is giving you way more decimal places than we have accuracy. So what you could do to alleviate that to the 2 decimal places is there's these 2 buttons up here. If you notice, hopefully you can follow my mouse right here. And it says decrease decimal places. We're going to go ahead and do that so it matches what we have. And it automatically, as you can see, rounds it as you need it. So kind of like before, if I want to replicate a calculation, you'll see that there's this dark box to the bottom right. Now if I hover my mouse over and it becomes a cross, I highlight and scan down, it has calculated all of our averages for us. And you could always double check, so 10.1, 10.2, 10.6, the average is 10.33. Ta-da! There you go. You don't have to do many calculations, which is really nice. So say you want to print out this data. Before I do that, first of all, it's really cool. So say, oh, I made a mistake here. This is not 5.12, maybe it's 5.24 or something like that. If you go ahead and do that and press enter, it automatically changes your value there, so you don't have to redo the calculation. So that's another really cool point to this. So so in some labs, maybe you need to do, this means nothing in physics, I'm just using it as an example, but say you need to actually square those times, square the average, actually there is some meaning, square time average time trials. You might have to do this in physics. I was kidding, this is actually something you may do. So if I double click there, I can do that. Now if I square it, it's going to be S squared, and what you can do is actually, if you highlight this and go to the format, you can ask it to superscript it, which makes it squared, right? So if I square it, I can do more calculations, right? So I could do this number squared. So again, I'm letting Excel do the calculations for me, putting an equal sign first, which is important, and then I could square that number by doing caret 2. And there's my square number. I could replicate all of that, and then I could go ahead and decrease it down to the decimal place that we used for more accuracy. I'm going to align it in the center like that. Pretty cool, right? So say we're going to do, I'm just going to do a calculation here. I'm going to say that this is a distance calculation. Always label what your calculation is when you do this. So I'm going to use a physics equation right now. Of course, this data is made up and it's not going to have any accuracy or relevance, but let's pretend we're going to calculate a distance. One distance equation is 1/2 times the acceleration due to gravity times t squared. So there you go. There's another way you can do that. So I'm doing a calculation, and then if I press enter, there we go. 1, 2, 3, 4. There you go. So very cool. So you can do all sorts of calculations here. If you need to square, you need to double, etc., like that. So something you might want to do in Excel is called standard deviation. It's an error analysis. So as it might, it's an error analysis idea, and it actually refers to how close you are to your, how much does your data vary from one another? That's your standard deviation. So that function is already in Excel. If I starting, it's actually under STD, standard deviation. So what I'm going to do, these are all sorts of things here. I'm just going to do the one that just standard deviation, STDV. So I'm going to go ahead, actually, this is fine, standard deviation. There's just a couple options here. I'm just making sure I'm choosing the right one. These are the old ones. Yeah, that's fine. We can use this one. So standard deviation of P population. So how close the numbers are to one another. So what you do is you highlight the 3 numbers here. The standard deviation calculation, if you Google it, it's actually quite complex. So using it on Excel is pretty simple. So this is on average how far the data is from the average, really. So the lower the standard deviation, the better your data. So let's see. So as you can see, the numbers that were close to one another, like the top 3, they're only off by a little bit, have a small standard deviation. But if you've noticed, I did some big jumps. Like if you look here, I have 6, 8, and 5. Notice how high that number is. That's a high standard deviation, which means that it's deviating about, on average, 0.9 from the average value, which is this here. So it gives you an idea of how precise your data is. Not necessarily accuracy, but how precise your data is to one another. So our first measurement was the best. And actually, I purposely did that to show you that this is the worst data point right here. So you can get an idea of how well your standard deviation is. So this right here is precise data, how close they are to one another. And this is not as precise in comparison to everything else. So on average, the average standard deviation, you can even do that, equals average. So go back to the average. Was about 0.35. And you can label that like right here, average standard deviation. So if you're doing error analysis, you could say, oh, my average standard deviation was 0.35. As I said before, the closer to 0, the better. So it's not bad. It's not great, but it's not bad. So just to show you too, what if you notice if I made these all the same value, 0.12, 0.12, 0.02, sorry, you'll see that your standard deviation is actually 0, and that's what you want. And let's be silly here. Let's change this to like some really crazy values. So notice that this is like nowhere near one another, and you can see that you have a standard deviation of about 8 right here. So that's pretty large. So I'm going to go ahead and undo that just because it's going to bother me otherwise. So you can see the difference. So precise data, standard deviation is pretty close to 0. And not precise data is when the standard deviation is really close like that. So let's say that you're done with your lab. Of course, as your instructor, I'm going to want to see all this. When it comes down to your calculations, things like averages, I don't need to see that. I know you understand an average. But I do want to see what you did for here. So if you squared the average time trials, tell me what you did for the calculation. That also includes over here as well. So if you're going to do a distance calculation, show me what that calculation was. Distance was 1/2 times g times t squared. So you don't have to show me, but tell me what your calculations was. So this is your average time trial squared. And then you don't need that, but rule of thumb, tell me how you did the calculation so that when I'm looking at your data that I can see that. Now when you print out this data, a couple things. Even though there's lines here, it doesn't actually print off the lines. So to make the lines, if you want something nice here, you go to this button and you say add all borders. So always, always, always make things look nice and easy to read. So you can do things like make this either bigger or a different color. If you do, make sure that things are not cut off. If you're copying this to a Word file, that's fine. But if you can see, if you want to be really fancy, you don't have to do this, but it just looks nice when you do. You can also do stuff like that. And look how easy it is to read when you do stuff like that. So it's good to add boxes to your data. Second is when you print this off, go to page layout and ask for print guidelines. Because what it does is says actually the paper will now end right here. And you notice that that will actually cut off all of your data. So to avoid that, first of all, go to narrow. So that gives you more, as you can see. So now it's all on 2 pages. You can actually orient it so it's landscape instead. Or what you can do if you want it on 1 page, or maybe I ask you for 1 page, is you can make these a little skinnier because the numbers are not very big, so that it all fits on 1 page. There you go. I don't need the precise data part. So now this is all squished. So what you can do is you can go back to home and you could do text wrap. In fact, if you do text wrap for all these and we go and do that, now you have it so that it is kind of stacked instead. So I can actually text wrap this a little bit and there we go. I don't care about this part, but this might be something you want to turn in. The final step is when you go to print, please look at your print view before you print, because otherwise you'll waste a lot of paper. Notice how everything's on the paper just like we want right here, so that's good. And then you could go ahead and you can select whatever you have. Where are we? I have, like, as you can see, a million different printers online. Oh yeah, I'm using my home computer, so it's not going to show up. But anyway, you pick the computer and you press print. And then always save your data as your the assignment and your last name. So this is Excel tutorial underscore your last name. And if you have lab partner, put your lab partner last name there too, just so I can find data and it's organized quite nicely. In fact, I'd also like you to put the class that you're in. So let's say you're in, it doesn't matter, you could be in physics 2, AP physics, whatever, physics. So do it by class name, the file, and then the 2 last names, and then you save. Now, depending on the lab, I might have you do this digitally, I might have you use a flash drive, I might have you print it out, so of course follow lab directions, and make sure that it's all together. And of course, it's always good to title your data so I know what I'm looking at. So it's not just, let's go ahead and fix this. So notice how descriptive this title is. I want to know exactly what the data means. These are distance and time measurements, so they're measurements of a ball rolling down an incline. And then, of course, we have all our calculations here. So this is what the data represents. So what specifically is this data? Is this a person walking? Is this a car on a ramp? So be very specific when you do that. So definitely do that. And then if the lab has a lab title, also add that in too. So you have your lab title like this. So just kind of in conclusion, these are the things I'd like on your labs, is of course your lab name, your lab class, the date that you did it. If you're doing partners, which is pretty logical, put the names of all your partners and the lab title, whatever the lab title is. So maybe it's on ramp. I'd like you to actually, I'm just going to make this look a little nicer here. I'm going to add, so what you can do is you can insert cells, as you can see here, so you can add some space. I'm just going to just spruce it up to make it look nice now. I'm going to put the equations, you can put them above, you can put them below. I'm just going to move them right now. Just doing some data cleanup here. That's a better, there you go. That's way better. I'm putting the title right there instead, and as you can see, you could do this all later. You don't need to do it. I mean, you could do it now, as you go, but that's actually the way I want you to have this presented on your Excel file. With the title right there, you can even write the word title. You don't have to. I understand that's a title, but this is how I'd like you to do this. It's important that you do title them because you might have to do two data sets. So you might have this is the ball on the ramp, and then you might have to do another set down here. So if that's the case, to save you time, you could always copy and paste, right? So, oops, I went too far here. Go back up. See? And then what you could do is you could, if you clear out the data right here, you could add in your new data for the next one. Say this is your new data for the following one, etc. And the cool thing about doing this, if you notice, is that it's already doing all your calculations for you, including standard deviation, just like that. So it's a really cool feature. Okay. At this point, it concludes our video. Sorry, I lied. It's a little more than 15 minutes. It's a little more like 30 minutes. I'll make that adjustment in my PowerPoint. But I hope you got a general idea of how to use Excel, what I expect you to do with Excel, and how to present your data. If you have any questions, as always, you can do my email. You can do ngranucci@sacredhearthamden.org, or you could talk to me before or after class. Have a nice day.